So in this class, we talk about how to deal with the stochastic problems, so which is the next step from the deterministic mathematical programming models. Before I talk about what is a simulation, let's start from what we have learned this course. We actually start from a simple linear programming model. We actually mentioned before linear programming model with a continuous variable and a single objective. And then we move up. We talk about integer programming or mixed integer programming. We talk about it's possible to consider integer variables or binary variables and still single objective problem. And then we extend the study to Go programming. We talk about both continuous or integer. It's possible for integer variable and multiple objectives. Today we continue to going up because in all the previous 3 studies we all assume we have deterministic parameters. So everything are pre-known, then we can build a model, try to solve it. So what if we have a stochastic parameter and all the other quantitative information or relationship? Then the previous method will no longer work, so this time we need to use simulation. Of course, there are also stochastic programming methods, which are actually not covered in this course. So we will just focus on one new method called simulation. Here we have a theory's definition for simulation. So what is a simulation? Simulation is trying to duplicate the features, appearance, and the characteristics of a real system, imitate a real-world situation mathematically, study its properties and operating characteristics, draw conclusions, and make action decisions based on the results. This is actually very difficult for you to know what is a simulation by a definition. Here, I want you to just notice we're dealing with a real-world system. So the real simulation including different types. This can be a numerical simulation, Monte Carlo simulation, or we can do computer simulation. For example, we can imitate a factory's production process in your computer and then collect the statistics from running the simulation or the computer model for a certain time or multiple replications. And we can also use Excel, basically just build a mathematical model, do calculations, but integrate the stochastic factors. Here, very important contribution is how can we actually use a simulation model to draw the conclusion. Later on, we will see what kind of solution simulation models can provide. So, this slide summarizes the difference between the linear programming models and the simulation models again. We have actually mentioned this before. So now I want you to see the highlights in the simulation models. So first, we are allowed to consider stochastic factor in the simulation model. For example, you have a demand, which are not certain in the future, And we have a system, you want to make decisions in a dynamic decision status, so probably longer period, allow the interactions. And the simulation also allows you to try different alternatives. So actually, simulation is an experiment. So the structure can be very flexible. So later on from the examples you can see, as long as you can somehow do the statistics or calculations is okay. So even no need to be linear. As we said, the simulation method is also a mathematical programming method. So we start from define a problem and introduce important variables. In the RP model, we actually define variables. Later on, we find a solution for the variables. So here in the simulation, we actually need to set values for these variables through your experiments. So next step, construct a simulation model. This can be a quantitative model, can be a real-world business process model, and so on. So specific values of variables to be tested, and then conduct a simulation. For example, you run multiple replications, you do a lot of experiments, and then examine the result. So here the result normally is also stochastic. Need to do a serious statistical analysis, then you can make conclusions. So examine the results. If the results are not reliable, you may need to go back to do more experiments. And so this test, the values can be considered as experiments. So if the results are cannot be validated, then you need to actually further revise your model or verify the model in order to get a reliable solution. So this is just a very rough structure about the simulation method. This slide shows possible situations you can do a simulation study. For example, for ambulance location and dispatching, assembly line balancing, parking lot and hub design, distribution system design, so scheduling or aircraft, labor hiring decisions, personnel scheduling, so plan layout. It's a very common production scheduling and bus scheduling, ambulance location. I happened to teach simulation courses in to different students. They actually have tried all these projects in the previous years, so that's quite actually popular tool to use simulation to solve this type of problems. Before we really started to build a simulation model, I think that's also necessary for you to know when you should think about to do a simulation study or when you should not do a simulation study. This is clearly related to the advantages of the simulation and disadvantages of simulation. So first, the advantages. Of course, the simulation model does not need a fixed standard structure, so everything can be integrated. So the model can be very flexible. So it's easy to handle large and complex systems. and also straightforward because normally it's imitate the real world system, so it's straightforward and flexible, and can handle complications and interactions between variables. Can answer what if questions because it's basically do experiments. So it's a real world system. Does not disturb influence the real system because it's normally built in computer, not in practice. Allows for time compression because the simulation clock is used, which is computing time. It's not a real world time, so it's a lot shorter. Many types of software are available, so for different types of problems you may use different types of softwares. You can do Arena, Risk, Crystal Ball. So many options. Unfortunately, there are also some disadvantages. So simulation can be very time consuming and expensive to develop and run because you need to collect data, do an interview, and a lot of actions. It's really time consuming and does not provide optimal solutions to the problem at hand. So that's actually normally described as a random in and random out. Because when you consider stochastic factors as an input, of course the output is also random. Just will also be time consuming to interpret your result. So every simulation model is unique and its solutions are usually not easily transferable because the solution is not optimal. So normally it's hard to draw the structure. So no structural results. Now let's see how to do a Monte Carlo simulation. So Monte Carlo simulation means you can use probability distributions to simulate the random factors in your problem. For example, the prices of materials or the demand of a product, temperature, many factors can be stochastic, but if we simulate model all these stochastic factors by the probability distributions, then this can be considered as a Monte Carlo simulation. Use random numbers to generate values for the variables in the simulation model. So this actually also two things included. One is we need a random number generator. We also need a random variant generator. So that's different things. So random number is a uniform distributed in the range 0 to 1. Random variable actually is the real stochastic values you're interested in. For example, demand, price. And then the third step, repeat the process. So in the simulation, normally need to run multiple experiments because you have to try here different random values for a problem, multiple random values. The last step is evaluate the result. Now you can see if you get multiple replications, then you have multiple results. So you need actually a statistical tool to draw conclusion. So what is random numbers? So random numbers is the uniform distributed numbers in the range 0 to 1. So they're actually a method to always be able to transfer a random number in the range 0 to 1 into a random variable or random variable value. Then this can be any kind of distributions. So random number generator actually is a very important. So here, random number generator is critical for a simulation model or simulation tool. For example, in our model, we use Excel. Then the Excel is a simulation tool. Then the random number generator is actually the function, rand function. In different tools, you could have different random number generator, but here you just need to know in the Excel we use rand. So random numbers are used to generate random values for a parameter or variable. For example, generate a random number and then you can transform. So we say transform the random number into a random variable. That's a general method. But in Excel, you can directly generate random variance or random values. We'll see that later. So in this course, we use computer programs to generate values for stochastic factors directly based on different probability distributions. These are some commonly used probability distributions. So a probability distribution can come from different places. Can be drawn from empirical data. For example, you count the occurrences and divide it by the sample size. Then they got a proportions of each occurrences or possibility. Or you choose a known probability distribution. This is actually very popular. You can do normal distribution, uniform distribution, triangular distribution, Poisson distribution, variable distribution, or many more. We assume that we know with certainty what distribution the variables follow. So in this course, so the no need to fit distributions. Now let's see how to generate random values or stochastic values in Excel. Uniformly distributed random number on the interval 0 to 1 is actually the standard Excel system function rand. And then we can see if a distribution in the range A to B, 0 to B, then you can use here this function. And if you have a uniformly distributed random factor and in the range A to B, then you use this function A plus rand times this. So the last one, the discrete uniformly distributed random number in the set A until B. So all the integers you can see in the range A to B, then you can use a specific function random between A to B. So you just draw the uniformly integer values between A to B. For example, you have a value, you would like to draw a value from 3, 4, 5 to 10. And then you can just write rand between 3 to 10. We continue to see how to generate random values in Excel. So if you have a stochastic variable and a discrete probability distribution with two outcomes A and B, then the probability P for A to B is generated by the function if. So here basically this means if you generate a value rand equals to 0.4, then if P equals to 0.5, then you generate a value x equals to A. So if you generate a value rand equals to 0.8, then you generate another value is B. So that's basically that's our option function. And this idea can be extended to discrete distributions with multiple outcomes. So now you see if you have the option possibilities for the demand 40 units, 45 units, 50 units, 55 or 90 units, probability is 5%, 10%, 30%, 30%, 25%. Then in Excel, you can use a lookup function. Then you can actually generate values which falls into different categories of the demand values. So here we use an example later to show you. It will take some time to explain how to implement this. So this is actually important part to study. Last, we also have a normal distribution. So normal distribution in Excel is very easy to draw inverse function for the variable values. So you just directly draw a normal distribution, inverse normal distribution function. So this actually means if you have a stochastic variable which obeys a normal distribution, then in order to generate a value for x given certain probability, then the probability is given by rand. So if the probability given by rand function, then you can get x equals to normal inverse rand mu and sigma. And on the other way, actually, it also means rand equals to normal distribution x mu delta 1. So it's a accumulated distribution. Now we use a book example to show how to actually go through the simulation process. So this example is called Harris Auto Shop. So this shop sells radical tires. So it's a type of product, and the demand for these products actually are stochastic. So historical demand, you can see the demand at the different quantity levels with different frequencies, and the probability of each scenario also given. So obviously the demand is not static, it's not certain, so it's a typical demand uncertainty problem. Then next step is how can we actually first model or simulate the demand, the scenarios of the market. So when you collect the historical data, so you normally get the demand variances and frequencies. So probability is calculated by the frequencies. So the total frequencies equals to 60. So for each different scenarios, so 1, 2, 3, 4, 5, 6, you calculate the probability by the frequencies divided by the total sales frequencies. So we first studied the demand of this shop, those short-term and long-term values. So first let's see the expected monthly demand. So that should be the long-term demand. So you know the probability and we know the demand value. So the weighted sum will be the expected demand. It's commonly seen and accepted if you build a simulation model. So now, in the short run, we know every month the demand actually fluctuates a lot, from 300 to 400. So it would be interesting to look into how this fluctuating demand will affect the company's profits. In order to do such an analysis, we need to actually generate a lot of different demands for a certain longer period. In this case, we need to calculate cumulative probability for each scenario. Then we can use a lookup function to generate random values. For example, for the scenario 300, so in the first 5% probability, you can allocate the demand is 300. Then from 0.05 to 0.15, then that's 320. So it's basic. From 0 to 0.5 should be open. So it's the second scenario is from 0.05 to 0.15. Then you can generate different intervals for your random numbers and corresponding to different demand values. So if we use a random number in the range 0 to 99, then that's probably easy to understand. So if your random number is 0 to 4, then you generate a demand equals to 300. So if you generate a random number in the range 5 to 14, then you generate a demand 320. So that's the uniform discrete distributions. So we can bring this idea into Excel. Then you have actually the upper limits and the lower limit for each interval. Then you get 0 to 0.05, and you get 0.05 to 0.15, then you took 15 to 0.35. So you generate all these intervals, and then you tell these intervals to lookup function. So now you can see, the lookup value of the random number is C9. So this is the random number you generated, which in the range 0 to 1. And then C2 to C7 actually is the range you look into. And if the value less than this value in C2 to C7, then you get the corresponding demand. And A2 to A7 is the simulated value, or we see this actually is the demand you generated. So that's how you use a lookup function. What you look up. We can write an example for lookup function. For example, you look up and C9 equals to rand. For any random number, you get a number 0.13. Then you look up a value 0 is 13 in the range C2 to C7, and you want to return a value in the range A2 to A7, then you can find this value is in this range, in the second range, so corresponding to a value of A2, A3, so equals to 320. So in Excel, of course, you decide how many demands you want to generate. Here is another example. You generate a random number equals to 0, 7, 15, and then you generate a demand equals to 320. And this demand will be used to calculate profits of the company. Of course, here you only generate one scenario, one demand. When we do a simulation, you probably need to generate a lot of demand in order to calculate expected profit. So the real simulation actually always need a quantitative model to decide what is your performance merits. So in this problem, we're actually interested in the total monthly profit margin for this company. So the demand is the stochastic, and the price is given. The price is average selling price. And here the interesting part is the M, the profit margin. I'll change the color. So the profit margin actually is also stochastic. So the demand is also stochastic factor. And minus F, fixed costs. So we do not have actually other method to solve this problem. That's why we do a simulation. The idea is if you can generate a lot of values for demands and for profit margin, then you can calculate a lot of different possibilities for your total profit margin. Here the price is the average selling price per tire. So this actually also a random value between 60 to 80. So we put the idea in the Excel calculation. Now you can see this is the setting, probable setting, or you can name this as a simulation model. This model includes different parts. So you have actually the target. We're interested in the profit of the company, of the shop. So this part is a parameter for the lookup function. Then you can actually use this lookup function to generate demand. And here the first random number is actually related to the demand. And here the random 2 is another random factor related random number. It's a profit margin. And this rand is used in this lookup function. So this random number is used in the profit margin calculation, and we actually have the third random number. So this actually is a random number value. Random value 3 is also a uniform between 60 to 80. Now, if you know how to calculate profits and how to generate random numbers, so this setting up will help you to do one single calculation for profit. So you basically have one set specific value for D, P, M, and F. And then if we name this as 1, the first experiment, then you call it experiment 1, or sometimes we call it replication 1. This table shows the specific output of one experiment. So this is an output of one set of data, or we say one experiment or replication. So the profit is $4,125. And the generated demand is 300, the selling price is 72, profit margin is 28.36. So now you can see a set of data is we generated a set of values for your parameters. So however, a single run of simulation means nothing. So in order to get the overview of the performance of this shop, we need to run multiple replications. That's very important because you change the parameter values, then the output will also change. So which replication is most representative is actually cannot be decided. So we need to do multiple replications to collect a sample of the output. Then you do analysis based on the sample. We can see this in the continuously in the Harris Auto Shop example. So now you can see everything set up, but it's only for the first application. So now we are interested in the overview performance, or for example in 200 months. So we would like to run 200 replications, or we do 200 experiments. What's going to happen? So in this part, there is one new thing I want you to learn. It's called a data table. So if you have gone through the textbook, you should know the data table is a tool in the what if analysis. So if you go to the menu data, click what if analysis, then you can find the data table. About how to use a data table, you can check the textbook. So in the textbook related section. Apart from that, I will do a video, so a screen recording for the next example. So for production planning example, So you will see how to do that in that video. So here I just skip that. But here the data table gives us the probability to run multiple replications. So if you want to run 200 replications, you set up 200 cells for the output of the profits. Then you set up values only for the first line, first row in data table. After you do that, you click run and you get the output for 200 scenarios. So that's what I mentioned before. So this is a screenshot for the data table. So now you can see you choose the input range and you choose you would like to do columns or the rows, and then you set up values for that. And this is a data table editing dialog. So here is a descriptive statistics result. So this actually is also in a data package, and you choose a data analysis. So in the analyze tab, analyzer, and you choose data analysis, and then you can choose descriptive statistics. The results, this output, this table give you some critical values. So for example, the mean over the 200 replications is 4,320 per month. And you know the confidence interval. So basically it's a 95% of the chance the shop's profit will be in the range to and then you can also find the standard deviation and the median, and of course maximum and minimum. That value actually quite interesting. You can see sometimes the profit is really low, sometimes the profit is rather high. So this is what I would like to say about Monte Carlo simulation. It's very important you go through the textbook, find all the technical details and work them out. And the next step, you should look into the extra example put online. I will do a screen recording to show you what's going on in that problem and what's the results. Thank you for that.